Hello and welcome to Aerotech's Automation1 instructional video series. Aerotech is a company that solves your toughest precision motion and automation challenges. Automation1 is a motion control platform consisting of software-based controls and development tools, plus hardware-based drives for servo motors and other devices. In this video, we will have a high-level overview of the Automation1 Studio application. My name is Patrick Wheeler and I am a product manager for Aerotech. Let's talk about the Automation1 Studio and what it is. The Automation1 Studio application is a main development tool for the Automation1 motion control platform. It is a part of the Automation1 Motion Development Kit, or MDK, which also includes the Automation1 Status Utility, Console, and the Automation1 Controller APIs. The Automation1 Studio is used to configure, program, and analyze controller level and drive level functionality within the Automation1 platform. It's also used to develop Aeroscript programs. Aeroscript is a programming language developed by Aerotech for Automation1 real-time application code. Now let's remember that Automation1 is a precision motion control platform. And that means it consists of software or development tools, controllers, drives, and connectivity for the sake of precision motion at the micron and nano level of motion control. Let's take a look at the Automation1 Studio application. Here we are at the welcome screen for the Automation1 Studio application. This is where you choose to connect to a controller or work without a controller. For this overview demonstration, we will connect to the local controller that's a PC-based controller on the same PC that I'm currently using the software on. I'll simply choose to connect. Once connected for the first time in Automation1 Studio, you'll see that my controller is stopped, it's unnamed, and it asks me to go to machine setup. Before we do that, a quick overview of the application shows that there is an application toolbar where the controller name is and the status of the controller is displayed. Underneath that, there's a workspace bar with the configure, develop, visualize, and machine apps workspaces called out, as well as the start screen of which we're on currently. To the far right-hand side, you'll see that there's a sidebar with many different sidebar functionalities that we will go into later. And down below, there's what's called the Axis dashboard that is completely empty right now until we set up our system. So we'll go to machine setup as the application instructs us. Now that we're in machine setup, we quickly pick to use virtual communication because we're connected to no actual hardware. The controller is now running. We can name our controller. We'll name it Test System. Next, because this is a motion control platform that has drives and connects to actual physical mechanical devices, we will add those devices to our control scheme. First, our drives are electrical devices. We are going to pick the XC2 servo motor drive from Aerotech and configure it in the application as it was configured when we bought it. We'll pretend we're having a 2-axis system today, so we'll simply duplicate the number of drives in the system, move on, and add our stages or mechanical devices. We'll simply filter for the mechanical device we're using, in this case a Pro 115 ball screw stage with a BMS 60 servo motor driving the ball screw. Again, we're configuring it as we configured it when we purchased the product. We'll simply add that. And again, we'll duplicate this just like the electrical device. And move on to interconnectivity, where we're simply drag and drop the mechanical devices to mate with the electrical device to create axes. Axes are the main programming construct we have inside the Develop Workspace. Here you'll see we're actually setting 34 parameters by making these choices. We'll complete machine setup, close out, and you'll see the application jumps us to a series of checklist items to perform on the axes to finalize the configuration of each axis. For both X and Y, we get this list of items. So just for an example, if you wanted to go through this complete list, you might use the blue button here to go to that portion of the Configure Workspace. And the Configure Workspace is exactly what it says it is. It's the space you go to configure your system. The Develop Workspace is a space you go to develop your application, and Visualize is where you go to visualize feedback from your controller and your drives. So we jump to limits right here. And just to show you a little bit about the sidebar functionality, that's where this checklist feature shows up. Also, if I wanted to get a little more help on these limits, I can click on the limit parameter entry point and get some more description on exactly what the end of travel limit setup parameter is and how I might want to set this up. So we'll go back to the checklist and we'll just pretend we've gone through all of our checklist items and we're ready to set up our homing routine. We go here, we set up our home speed to be 60, our ramp rate to be 500. We apply these changes. We can save them all. I will do it in a minute. I'll say this is completed. We'll go to Easy Tune. If we were not in virtual mode, I would simply hit start and run a tuning operation for the servo control loop. We'll say we did that, and we'll save all of our parameters in the Configure Workspace. You might have noticed the orange warning that came up. That warning is not terribly significant, but it is a good opportunity to show where notifications are actually logged inside of the sidebar. So here you'll see a list of all log notifications and active notifications. We can simply dismiss all notifications at this point. Jumping back in the sidebar, you'll see that the other features of this sidebar include your controller overview, which will allow you to disconnect your controller and go back to your welcome screen, your notifications, a tool called Quick Navigation, which will allow you to go to any topic you like to search for in the application. So for example, if I want to find my primary feedback, you'll see I can simply search for it and find all the different parameters that are associated with my primary feedback device, hit enter, and I quickly jump to that spot in the application. If I want to get back to where I was before, I can do something as easy as type Easy Tune, click on Easy Tune, and Quick Navigation jumps me back in the spot in the application which I desire to be. Another tool that came online in the last release was Quick Compare. I can compare axes and tasks within the controller. So right now I'm on the X and the X, so there's nothing to compare. But if I would go to the Y, you'll see that the different homing parameters I changed show up. It shows the things that are different, okay? So I changed that value, and sure enough, if I went to the advanced editing here and saw the equivalent X parameters, you would see that this is home speed is 60 on the X and 40 on the Y. Now, if I went in and changed this back to 40 on the X, it would go away from this quick compare tool. It would fall out of the comparison. Checklist we already went over, and the help we already went over as well. So going back to the main application, you'll see that the application toolbar also includes 3 buttons for controlling the controller. The first resets it. The second would acknowledge any controller faults and clears all task errors and warnings. And the third one is an abort button, which aborts motion on all axes and stops programs on the tasks. To the right here, there are settings which offer you the ability to configure application-wide settings. And finally, in the Configure Workspace, there's 3 levels of parameters you can control. There's controller or system-wide parameters and settings that you can set up, including calibration, your controller file system, data collection, infinite field of view, which is a controller feature, programming, including the number of global, reals, integers, and strings available to you. You can increase those. Some protective features, our signal log, which is a part of motion health, and our transformations. There's several different axes parameters that can be configured as well. We just went through many of those in our example and machine setup. And then finally, the same for axes. You might have noticed that after we went through machine setup, X and Y axes were populated on the axis dashboard. You can also enable your jog buttons, where you can enable your axis and jog forward, jog reverse right here from this screen. And then you can also home the axis as well. If you want to change some of the settings on the jog, it's accessible right from the axis dashboard. You can change from speed-based to distance-based jogging. If you do that, you'll see when I hit forward, I'll jog 5 units. When I jog back, I'll jog back 5 units. That's distance-based jogging, which is configurable there. All the same tools are available for every axis on the dashboard. If you want to show some axes that were not configured in machine setup, simply click on any one of the axis parameter categories, click Manage Axes, hit Yes, and you'll see the Manage Axes screen where you can display other axes that were not set up in machine setup. Simply save your changes and watch the axis dashboard be populated with additional, in this case, 4 axes. Moving over to the Develop Workspace, this is a workspace where you actually develop your application code, your Aeroscript code. In the Develop Workspace, there's 3 main areas. One is a programming module. The second is a module container that contains your variable and IO module, your task status module, and your program automation module. So a lot is going on in this section right here, a lot of nice user features. And then down at the bottom, you have your data visualizer. This is digital oscilloscope visualizing information or data from the controller or the drives. I'm going to open a program that I've already developed just to show you a little bit about Aeroscript. And that program, first one is Move 10 in Aeroscript. This is a very simple program that shows you a couple of different things going on. The first is that triggering is enabling and homing an axis from the programming language, triggering data collection, and then also viewing a global integer being set, which we can view here. And I'll show you one extra thing is if you actually star these, and that applies to drive IO as well, these will show up in your favorites tab, which I'll show you here, okay? So the iGlobal 0, which is in my program, is saved to a favorite. When I build this, load it, and run it, you'll see that that updated to 35, so I can use this as a watch window. And I collected real data here on my data visualizer as I moved. If I'm not happy with the signals I'm collecting, and I want to see the actual position command changing for my x-axis, I can do this and add that signal to my list. I can change the color for that as well. If I don't want it to be this light blue, I want it to be a different color. And then also if I'd like to collect 2D data, which I'll be using later on in this example, I simply add that as well. And then I can make this into a nice dark blue if I'd like. I can update that, minimize this again. And then when I run this program again, I will see that actual position command move from 0 to 10. So this little button here, I kind of skipped over this single command prompt here, but let's touch base on that. If I wanted to actually run commands, not from my programming workspace, but just send single line commands to the controller, almost like a mini console application, I can do that here. So for example, if I wanted to disable my x-axis, I can simply do that, and you see it's disabled in the application. I can enable X, I could home X, and I could move linear X 10 and move X to 10. And then if I wanted to access the history of my commands, I could rehome X and it goes back to 0. Another thing I'd like to show you here is that going back to the Configure Workspace, I can add additional tasks to my controller by going to the Manage Tasks interface. I simply do this and add a couple of tasks. I can name these things as my motion task. If I have a PLC or a process automation, I can name that as well. I'll save my changes. Quickly head back to the Develop Workspace, and you'll see this program. I can add in this process automation task here, and I can drop it here, and now that task will run on task process automation when I run it, not task 1, which will free up my motion task for other things such as immediate commands. If I want to see this data in the Visualize Workspace, I can either go there directly, or I can choose to stay on Develop, and then I can open up a second instance of Automation1 Studio and use a 2-monitor layout and click over here to the Visualize Workspace and maybe have this over on my second monitor. So that's also possible. And the last thing I want to show you is another set of programs that I have here for this demonstration. This demonstrates the ability to use library files in Automation1. So in this program example, I've written a custom motion command called move custom with a library file. I'll open that up and show it to you real quick. So this library file has a custom enumeration called custom move triangle or rectangle, and based upon what you choose in your function call, you'll either do the triangle moves here that I've programmed or the rectangular moves here. And I'll show you exactly what that looks like just in a second. The way to actually add this library to your controller is to come over to the program automation compiled libraries and add a library. And my custom move A1 library file, which is a compiled library file, and I'll choose to keep that as an auto import file, hit save all, and hit yes. So now that's there, that's available to use. If I run this motion test, I don't need to include it because it's auto included. So I don't need to tell this program to look for it. And then I can build this file, load it on the controller, and simply run it. It's collecting the data for that motion right now. You'll see that I did not collect the full shape. So what I'll do is go into my configure signal dialog again, and I can increase the number of points that I'm actually collecting so that I make sure I can collect the full set of data. Run this one more time. And now you see that the custom move rectangle and triangle at a 45-degree rotation, a length of 25 and height of 10 was actually created. Both these were created. I can make this larger to show you that and zoom in. And then I also can show you this in a split screen 1D and 2D plots. So that's all very nice, and that's all possible to do within the Automation1 Studio application. Let's minimize this. That concludes this instructional video. Thank you for watching. I hope you enjoyed learning about the Automation1 Studio application.